Alright, problem 3-26. Find an equation for each sequence below, then describe its graph. We'll start out here with letter A. We've got a sequence here listed. We've got 3 terms. The third term is 8. The fifth term is 2. The seventh term is -4. When we look at this, we're increasing our term number by 2 each time. So as we go from 3 to 5, we know that we're going up 2 terms, and then we're going up 2 more terms right here. So that'll make it a little bit easier for us to compare the actual, from our term number to our terms. So the actual term decreases as we go from 8, which is the third term, to the fifth term, which is 2. So it actually is going down by 6. And it's doing the same thing here. When we go from the fifth term to the seventh term, we go from 2 to -4, which is also going down 6. So this looks like it's a constant rate of change, which means that we were looking at like linear growth. And with that, so we're thinking about this sequence is going to be an arithmetic sequence. Now, if we forgot what an arithmetic sequence looks like, that's when we're taking a pattern of numbers here, and we are either increasing or decreasing by adding the same amount each time. Or some people think of it if it's decreasing as subtracting. But it should end up giving us something in the form of, t of n equals common difference times n plus or minus a starting value. So that's what we need to find here. We need to find the common difference. And we need to find our starting value, which is like some people refer to it as the 0th term. If this was a function, it would be like our y-intercept. So when we're looking for the common difference, we've already figured out for every 2 values, or every 2 terms we go up, we go down 6. So we can treat it like its slope and just do a number minus the number before it. So when we do -4 minus 2, we should get -6. I'll just show you how it looks like slope formula. -4 minus the previous term. And then 7 minus the previous term number, so 7 minus 5. And we see that we get -6 over 2, which makes sense because that's what we already have there. But that means when we are looking at the difference between each term number, when we go up one term number, it's going to go change our term by just 3. So we're going to say -3 for each term. So our common difference is -3. Our pattern basically means it's going to go down 3 from term to term. Our 0th term can be found by either treating it like it's a function and finding the y-intercept, or you can just look at the pattern and go backwards too. If we know that the third term is 8, that means our second term, if we're looking at our second term, remember this is going up by 2 this way, but if I'm going back just 1 here, that means that I have to add 3 to go backwards. So when we add 3 to 8, we should be at 11. To get our first term in the sequence, we would add 3 again. And that would give us 14. And our 0th term, I'll just write it right up here, would end up being like 17. So our 0th term is 17. So when we write out the actual equation here, we would say that t of n is equal to, we're starting at 17, and we're going to take away 3 over and over again. I know it says -6 here, but remember that's for 2 terms. We're going to be taking away 3 each time. So we're going to go down 3 n number of times. So that is our equation for this arithmetic sequence. Now it also asks us to describe the graph, and I'll describe the graph here in just a moment. I'm going to go ahead and take care of B first. So let's go ahead here, we'll do B in blue. This one, you notice here that the term numbers are increasing by 1 each time. So that's going up by 1. And this one's going up by 1. So that's consistent on this side, so we can really compare what's happening over here on the right side. So 40 to 32, we see that that is going down by 8. And then when we go down again, it's not going down 8 this time. It looks like it's going down about 6.4. So that means here this is not a constant rate of change here. Like it's not going down at the exact same amount every time, which means it's not going to be arithmetic. But chances are here that this is probably going to end up being like an exponential function or geometric sequence, in which case we take it and we have to have a multiplier to get from one thing to the next. So to figure out what we multiplied 40 by to get 32, we can take 32 and we can divide it by the term before it. This is going to find our common ratio. So the common ratio, when we do 32 divided by 40, okay, well that fraction reduces to 4/5, which is the same thing as 0.8 if you're a decimal person. And if 25.6, if we take the ratio of it to 32 and it's the same thing, we know that we have this geometric sequence. So 25.6 divided by 32. So when we look at that there, we know that 32 goes into 256 8 times, right? But since we have a decimal, here we got to move it over 1, so this also gives us 8/10, or 0.8. So we can conclude that yes, this one is a geometric sequence. So when we're looking at it here, we still have to know this common ratio up here. This is important. Oops, that's supposed to be a star. And we also need to know our 0th term, or that starting term. So think about it here. If I'm going to take it and I'm going to erase these differences here that helped us to see that it was not arithmetic. Oh, we're doing blue. Let me switch the color there. All right. So what we're doing each time here is we are multiplying times 0.8 to get to the next term. We took this one, we multiplied it times 0.8. So to go backwards, we're going to have to take 40 and we are going to have to divide it by 0.8. And that should give us whatever this 0th term is going to be. So let's think about it here. If we did 40 divided by 0.8, well, that is the same thing as if we multiplied each of the top and bottom by 10. I'm just looking at a fraction that may be a little bit more comfortable to work with because there's no decimals. I know some of us don't like decimals. That'd be the same thing as multiplying 40 times 10 to get 400. 8/10 times 10 gives us 8. 8 goes into 400. Well, it goes into 45 times, and then we have an extra 0 here, so that would mean that that would be 50. So our 0th term here is 50. So when we take our information that we have, we're going to write out our equation. We're going to say t of n is going to equal what we started with, which would be 50. And we're going to multiply it by 0.8, 8/10, n number of times. So when we take this now and we look at describing the graphs, we already know this one's going to have the path of a line. But remember, this is discrete data, so we are not connecting the points. We are not going to connect these points. So I'm going to move this down here. I've already graphed it just to save time because I know how much fun it would be to watch me graph all the points. But I've recopied some tables down here so you can see what these graphs are going to look like. So remember, the 0th term is not actually in the sequence. The first number in the sequence is 14. Then we have 11, 8, 5, 2, -1, and so on. So you'll see I put a point. First term is 14, second term is 11, third term is 8, and so on as we go down. Now we don't connect these because this is discrete data. There is no 1.5 term. There is no 2.5 term. There's nothing between these here. That's why we just have a straight line here. Looks like it's going down, has a slope of -3. It's going down 3, right 1, down 3, right 1. The one on this side here, one was exponential decay. Remember, our 0th term would have been 50, would have been up here, but we don't plot that because it's not really a term in the sequence. The first term in the sequence is 40. The second term in the sequence is 32. The third term in the sequence here is 25.6. If I take 25.6 and I multiply it by 0.8, my fourth term that ends up being 20.48. So you see here it's starting to bend a little bit here, starting to level out some. Our fifth term would be 16.384, so that'd be about right here. Our sixth term would be about 13.1072. I don't know if it all fits on the screen or not, but you see it's coming from way up here and it's coming down and it's going to level off here when it gets to the x-axis. It'll never touch the x-axis. So hopefully that helps you with kind of being able to describe the graphs. You should be able to put that into words. If you have additional questions, please make sure you ask your teacher in class. This is problem 3-26. Thanks for watching.